Pressure drop calculation. This is the problem statement. Air at 25 degrees centigrade and 1 atmospheric pressure flows through a 4 millimeter diameter tube, and the average velocity of the air is 50 meter per second. The roughness of the tube is given. Epsilon is equal to 0.0015 millimeter, and friction factor equation is given, as you can see on the screen. Colebrook equation it is called, and its form is on the screen. So in this problem you have to calculate the friction factor of this tube, and as second part you have to determine the pressure drop per meter section of the tube, and the relation, or you can say the formula to calculate the pressure drop is given to you. Other data like density of air at the given temperature is given, and viscosity of air is also given. Theory. We will use here Newton's method to calculate the friction factor, because the friction factor equation given is a non-linear equation, and for that we will use Newton's method. In this method we do iterations, and the formula used is, you can see on the screen. Here we need functions capital F and its derivative capital F dash. We will discuss now how we will get the function required in the Newton-Raphson method. Here you see that this is the friction factor equation that is given to us. Then we manipulate this equation. All the expressions we will bring to the left part, so that in the right part there is 0, and then we define the left part as our function capital F. And because the function we have just defined is complex to convert to a programming language codes, so we try to simplify it. We have defined some new variables a and b, and then we apply those variables on the function equation, and we get this simplified equation. As you know that we need the derivative of the function, so here we differentiate that function, and the final result is this. Now here we come to the Scilab codes. Function f, or you can see the capital F, has been converted to Scilab codes like this, and the derivative of the same function has been converted to a function fn dash in Scilab codes. To calculate the pressure we have the formula here, and this formula has been converted to Scilab codes as a function get pressure drop, and the variables that we are passing to this function are friction factor, length, velocity, density and diameter of the tube, and then you can calculate delta P. This is the Newton-Raphson method converted to Scilab codes. Here it has been defined as a function get friction factor, and we are passing to it Reynolds number and K, that is the relative roughness, and then the variable inside the function, you can see the variables a and b. We have guessed some value of the friction factor, that is f nu, it is 0.01, and then we have run an infinite loop, while loop, and we have applied the Newton-Raphson method. Then we have compared it. We have compared the new value to the old value, and when it is very small, then we break the while loop, and then we take this friction factor new value as our final value. After defining all the functions, now we run the real codes. Here are the various constants: density, viscosity, diameter, length, average velocity and roughness, and after then k is equal to E by d is relative roughness. Then we calculated Reynolds number, and then we call the function get friction factor, and we passed Reynolds number and relative roughness, and this will give you the result using the Newton-Raphson method. And then get pressure drop has been called to calculate the pressure drop. Here is the final result. After running the Scilab codes, you will get friction factor equal to 0.029 and pressure drop will be 11,185.144 Newton per meter square.